next most common type, or you can see in your textbook, I think, in your lesson you would have seen. The same is done for resistance also. Right, this is a cube. I want to draw a cube. I hope I can draw a cube. And each edge is having a capacitor. I will draw a light one. Right, so this is a capacitor here. Right, similarly there is a capacitor over here. There is a capacitor on this face. Right, so there are 1 2 3 4 5 6 7 8 9 10 11 12. So there are 12 capacitors on this face or the edges of a single cube, and the question can arise in any ways. Suppose the first question I am dealing with, it is from two corners, right, on the same side, that is 1 and 4. I'm going to name it as 2, this is 3, so it becomes 1 2 3 4 5 6 7 and 8. Right, 8 edges, sorry, 8 corners. Right, this much is clear. You are given a diagram like this, and all of them are having capacitance value of C, and you are asked what is the equivalent capacitance if you are taking from the terminals from these two sides, that is two edges. Clear? Right? Now I will tell you how to solve it, but it is a very lengthy process, and then I will tell you a small equation by which you just have to by heart it, and the answer is there. But you have to understand the logic. That's why I'm going to tell how the circuit solving is done. Similarly guys, previously when I was taking the previous question star delta method, I took it fastly, wait for some time, repeatedly hear the same derivations or how this problem is solved. Within 1 second or first time you hear the question, you are not going to understand how it is done. Wait. Whenever you are having a star connection, wait for it, just convert it into delta. How can you convert it into delta? The delta's one side is always depending upon star's two sides, right? Anyways, let's move on. We are having a capacitor combination in a cubical, or I will say cubical skeleton form. Now how can I draw an equivalent circuit for this one? See guys, you require the terminals 1 and 4. Right, across 1 and 4 I drew it. Now let's start from 1. From 1 to 2 you are having a capacitor, it's splitting, right? Similarly charge will be splitting to 5 also. So from 1 I am going to draw a splitting like this. Right, 2 capacitors goes off. One is to 2 and the other is for 5. This much is clear. Now 2 and 5 are moving with each capacitors to a 0.6. So from this to 2 points, 2 capacitors like this, and they move towards a 0.6. This much is clear, right? Now do you see the same pattern in from 4 also? Yes, you have the same pattern from 4 also. So what would I am going to do from 4? See, it is splitting from to 3 and 8, right? 3 and 8. So I'm going to split like this. Right, let's make this one as 8 and this one as 3. Now 8 and 3 are reaching the 0.7 through a capacitor. So this is 3 and this is 7. This much is clear. Right, I have redrew the figure like this. But how many capacitors are coming here? 4 and 4. 8 capacitors further I have to put. Right. Now the problem C. Let's see here. Suppose a one terminal, I am connecting a voltage over here between these two guys. So a voltage V reaches here, V reaches here also, V here, V here. But each capacitor will be reducing the charge, right? Because it is storing the charge. So due to this capacitor, there is a fall in voltage here, that will be V minus Q by C, right? Where Q by C is a voltage generated or stored or taken by this capacitor. and from 5 or before the 5 capacitor also the voltage will be V minus Q by C, right? So you see at 2 as well as 5 point is having same potential, right? That is V minus Q by C, V minus Q by C. That means I can join these two guys. Similarly, I can join 8 and 3, the same method, right? Here V, here V minus Q by C, V minus Q by C. I'm going to redraw the central circuit again, guys. Now it becomes like this, 2 capacitors, right? Now let's make it like this. This is 2 and 5, right? This becomes 6, right? Or I could have made this one as well, then it would look beautiful, right? Similarly, 4 section, this is 2 and 5, sorry, not 2 and 5, this is 3 and 8, right? Then this is 7, right? Clear. Now let's move on to the figure. 1 and 4 is having a capacitor, right? So 1 and 4 is having a capacitor like this one, right? Now 6 and 7 also has a capacitor, so 6 and 7 is also having a capacitor, right? Now let's move on. Now 3 and 2 is having a capacitor, right? So 3 and 2 is here, so I require a capacitor. Now 5 and 8, right? This from this corner, 5 and 8 is also having a capacitor, so 5 and 8 can be drawn like this, having a capacitor, right? This is the equivalent circuit, guys. 1 2 3 4 5 6 7 8 9 10 11 and 12. You have 12 capacitors. This is the equivalent circuit of the above figure. I hope you understood, and all of them are C. Now how would you calculate? Right, this and all are C. C, 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 C and C. Now how would you calculate the equivalent capacitor, guys? Let's see. Right, I'm taking another pen. The above C, I'm going to keep it as it is, C, right? This C and this C are in parallel, means you are supposed to add them, so it becomes 2C, right? It becomes 2C, right? Now what happens? This 2C moves to this 2 and 5. Again the C and C are parallel, right? So it is again 2C, right? In between them C and C is parallel, so there is a 2C here. And this is C and C is parallel, so 2C here also. And this is C and C, again 2C, right? And then there is in between, there is just a C. The circuit is simplified, right? And you are asked, the question is from A and B, or between these two terminals. Clear? Now this 2C, C and 2C are in series, right? This section, this much section. 2C, C and 2C are in parallel, means 1 by 2C plus 1 by C plus 1 by 2C. You just to make 2 here, I will multiply with 2, so it becomes 4 divided by 2C, that is 1 by C equivalent, right? So it becomes 2 by C. So C equivalent will be C by 2. So if I redraw the circuit, it becomes like this. C, this is 2C, this is 2C, 2C, and here this will be C by 2, right? These three guys are replaced by C by 2. This much is clear? This 2C, right? Now 2C and C by 2 are in parallel. Parallel means I add them, right? So 2C plus C by 2 is 5C by 2. So in place of this figure, again I will redraw B, A, this is 2C, here it will be, sorry, this is 2C, 5C by 2, that is C. This much becomes right? Now these three capacitors are in series, that is 1 by 2C, that is again 1 by C equivalent, 1 by 2C, then 2 by 5C plus 1 by 2C. Reciprocal of these guys are to be added. So it is better to make all of these guys into 10C, right? So to make 10C it becomes 5, this is 4, because 5 into 2, right? Plus 5 divided by 10C, right? So it becomes what? 9 plus 5, right? So 9 plus 5 is how much? It is 13, sorry 14C by 10C, right? Then I can reduce it with 2, so that this becomes 7 it's not C, 7 divided by 5C, right? This is the calculation only. Now I'm in place of 7 by 5C, it was 1 by C equivalent, right? So what will be C equivalent to be? It will be 5C by 7. So the diagram again, sorry. So it becomes A, this is C, and here the C equivalent will be 5C by 7. Now you have to add these two guys for equivalent capacitance, C plus 5C by 7. So 7C plus 5C by 7, that is 12C by 7. That is your required capacitance. Guys, when you get these type of questions or for need, do you think this much step is preferable? No, you are supposed to get the answer like this in 1 second. So I will tell you the exact value for 3 conditions, right? I'm not going to draw the entire thing. If this is, that is the same cube, we are having a cube like this, right, with each of the value capacitors. I'm not going to draw the capacitors, guys. Now if the question is for edge diagonal, that is from here and here, this the one we have derived, this is called edge diagonal. The equivalent capacitance is 12 by 7 in this condition, okay, by hearted 12 by 7 C. Now if again I am going to write or draw the cube, the question is you are asked what will be the equivalent capacitance from phase diagonal. What do you mean by phase diagonal? This is one phase, this is another phase, so this becomes phase diagonal. In that condition the equivalent capacitance value is 4 by 3 C. Clear? This is for edge diagonal, this is for phase diagonal. Now in the case of body diagonal, that is again I am going to draw a cube, right, that is from this point and the opposite this edge. This is the body diagonal, right? If you are asked what is the equivalent capacitance for this condition, that is CA or equivalent capacitance will be 6 by 5 C. These 3 values you have to by heart if you want, or if you guys are preparing for NEET. This much is clear. You are given a question or a diagram like this. This is your A terminal, right? This is your B terminal. How would you solve this type of circuit and you are asked what is the equivalent capacitance? How would you solve it? Right, this is A, right? So this and all, these 3 bars don't have any connection with either B or A, so I will name this one as 1. This is another free thing, so it is 2, and this one, right? So this is again 1. This is B, this is A, right? This much is clear. So how many terminal I have to mark? A, 1, 2 and B. Between A and 1 you have a capacitor, right? Between 1 and 2 you find a capacitor. This is 1, okay, don't make it as this is 1 point, right? Between 2 and B, do you have a capacitor? No, you don't, right? So between whom and whom I have? Between 1 and B I have a capacitor, right? Right. Now what happens again? Similarly 2 and 1 is having a capacitor, so let's make this as 1 point and this is another capacitor. This much is clear. Now what is the equivalent capacitor? How would you find the answer? Or Similarly, do you have from 1 to 1 you have a capacitor, between 1 and 2 you have a capacitor, between 2 and 1 you have the capacitor, then between 1 and B you have a capacitor. You drew it correctly. Right. Now what is the equivalent capacitor here? Now what happens here, you have nothing in this place, right, between 2 and B. So whenever there is a circuit and there is an opening, then that circuit is ineffective. Here see, between 1 and B, but after that there is no connection. There is no connection between 2 and B, right? So this is not forming a loop at all. So it's just like an open circuit. So when you draw the equivalent here, it becomes A, then there is one's condition, right? Then there is this and there is a capacitor like this. Then B condition is removed. Right, you just have to find the equivalent capacitor here. It is actually an easy question if you understand the concept of it. This much is clear, right? So we are completing the chapter 2. Okay.